This lecture is on Unit 3.04, which is we're going to explore creating a class, a base class called temperature, and then we're going to use that to create two derived classes, Fahrenheit and Celsius. We're also going to implement an interface, the I comparable interface, and this is great because we don't have to write it. It's already in the C# library. Okay, so let's start off by looking at our program once it's finished and what it's going to do. I'm going to put in, it's going to compare two temperatures, and it's going to tell us, because you can't do this in your head, or I don't know anybody that can, take a Celsius, convert it to a Fahrenheit, and tell us which one is warmer or cooler. So that's what this one does. It tells us if the first temperature is warmer than the second, the same as the second, or cooler than the second. All right, let's get started. We're going to put in 0 degrees Celsius. I think we all know that 0 degrees Celsius is 32 degrees Fahrenheit. Okay, great. It says it's equal. All right, let's just do the opposite. Let's say 32 degrees Celsius is 0 degrees Fahrenheit. We know that's not true. All right, the first one is definitely warmer than the second. Okay, it looks like it's working well, so let's get started. We're going to start our program, of course, with our base class. We're going to have a class called temperature, and it's going to have one field. We're also going to make it abstract because it's going to include two abstract methods, so we have to make it abstract. And we're also going to use the I comparable interface in our base class, which means all our derived classes are going to have the compare to method in them. All right, so let's get started. We're going to go up here and we're going to add a class and call it temperature. All right, and we're going to make it abstract. Now recall that if you have an abstract class, you can't instantiate any objects with it. Okay, all an abstract class does is hold behaviors and fields for its derived classes, and it requires them to implement any abstract method in them. Okay, we're also going to include the I comparable interface, and we're going to make sure that is for temperatures. That's what we're going to be comparing. All right. Okay, we've got one field, and it's a double, temp, and we're going to use auto-generated getters and setters, and we're going to have a constructor. And the first one is going to be a default constructor. So we'll set our field to default value. All right, now we're going to make a parameterized constructor. And so we're going to pass in a double the temperature. That's about all we can pass in because that's the only thing there. All right, whoops. Okay, now let's go ahead and we're going to create, because we're going to have to be able to compare temperatures, whichever scale we use, we're going to require each of our derived classes to be able to be converted into the other scale. All right, so we're going to go ahead and we're going to create a get conversion because they're all going to need that. And we're going to go ahead and make the I interface abstract. And remember, it's going to return an int 0, -1, or 1 to let us know where it falls. Okay, and we're going to compare it, we're going to have to pass in a temperature object, right, to be able to compare it. Okay, remember, when you have an abstract method, you're not going to have any kind of implementation code for that method. All right, so we're done with temperature. All right, now we're going to go ahead and we're going to create, first let's start with Celsius. All right, so right click, whoops, and add the Celsius class. Okay, now that is a derived class of temperature, right? Okay, so what does that mean? It's going to have two abstract classes that have implementation code. get to conversion and compare to. And it's going to have the compare to because the temperature or the base class uses the iComparable interface. All right, so we'll make a chained constructor. And we don't have any new fields, so we can just leave that blank. Okay, now we're also going to have the constructor that passes in the temperature. Okay, and we're going to make that where where the one passes in is going to, we're going to go ahead and assign that to the field. Now it's time to go ahead and implement those abstract classes, and the one we're going to start with is the get conversion class, and I will explain why that's the one we need to start with. Public, and we have to override because it's in the parent class. Double get conversion. All right, now let's go ahead and make a double to hold our temperature once we convert it. And let's go ahead, whoops, I'm having trouble typing. Let's go ahead and return that to get rid of our red, even though we haven't. We're just going to be returning to 0 right now, right? Okay, now we're going to make new temp equals, and it's going to be the temperature, and it's going to be times 9 divided by 5 plus 32. And I need an equal sign in there, don't I? Temp times 9 divided by 5 plus 32. Okay, that looks good. Now, the reason we started with get conversion is because we are going to have a Fahrenheit object to be able to compare, to do the compare to, because right now we don't, and it's going to be confused because it won't know what it is. So we'll go ahead and start the Fahrenheit class. And I type right. Okay, Fahrenheit class. And again, it's going to inherit from temperature. And so then we can do our default constructor. I'm having trouble typing with this one. Okay, public Fahrenheit, and it's going to be default. And there's no new field, so we don't have to assign anything. All right, and then we're going to go ahead and we're going to do one where we pass in the value for our temperature. Go ahead and put that down there. And so this temp for the Fahrenheit object equals the temperature we passed in. Okay, now let's go ahead and do the get conversion for Fahrenheit. All right, and we're going to do the same thing. We're going to create a variable, whoops, that is going to hold that converted temperature that we passed back. Okay, and we're going to calculate it differently though, of course. So if you're converting Fahrenheit to Celsius, this temp, I could just use temp. Temp, I probably ought to use this since I've used it, another temp somewhere in my program, just to be sure. Okay, this temp minus 32, and then you multiply that by 5 divided by 9. Okay, great. All right, so we've got the basics of our Celsius and Fahrenheit, but now we have to do the compare to. Okay, so compare to. We're going back to our Celsius, all right, and we're going to do the public override. And remember, with our compare to, it's either going to return a 0 if they're the same, a -1 if our object is less than the one passed in, and a +1 if our object is greater than the one passed in. So it's going to be an integer. And we're going to do this. All right, so now, before we start comparing, we've got to figure out what kind of object we're dealing with, because they can compare to Celsius, or they might compare Celsius with a Fahrenheit. So we're going to see if T is a Celsius, which is going to be the easiest case, because we're not going to have to do any kind of converting, right? All right, so if T is Celsius, okay, so if this temperature equals the temperature that we passed in, okay, that's easy. We're going to return 0. But if this temperature is less than the temperature that we passed in, and I didn't put that on the other one, did I? We're going to return -1. Because we can't just compare the object, we've got to compare that object's temperature. Sorry about that. All right, so if this temperature equals the temperature that was assigned to the object passed in, then it's the same, return 0. But if this temperature is less than the temperature of the object that passed in, we're going to return -1. And if that neither one is the case, we're going to do what? Because it's got to be one of 3, right? We're going to return 1. All right, now, we took care of one case if we're comparing to Celsius. Now we have to do the other case, which is if we're comparing a Fahrenheit to a Celsius. Okay, so if T is Fahrenheit, we're going to have to handle that differently. Okay, so now if this temp equals T dot, and we're going to use the get conversion method. We're going to return 0. Okay, now the only problem we have with that is that when you're making the conversions, it's possible that it's going to round differently, and so the decimal places might not be right. There's a couple of ways that we can take care of that. I think what we need to do is just go ahead and make it an integer, cast it to an integer. Okay, so if this temp equals the converted Fahrenheit temp, you know what I'm going to do though? Instead of just making an integer, I'm going to use the math round because I think that would be more accurate. Math.round, and we're going to round it so that it only has, it doesn't have any decimal places. Okay, that works. That works. Okay, so if this temperature is the same once we round it off of the Fahrenheit temperature, round it off to 0 decimal places, return 0. Okay, so if this, else if this temp is less than the math.round t.get conversion, and that's to 0 decimal places. Okay, so if this temp is less than the other rounded temperature that was passed in, we're going to return -1. All right, I'm probably missing a, yes, missing a parentheses. Okay, great. And I also misspelled return. Okay, now we only have one more case, else, and that is going to be a 1. Oh, as a return 1. Okay, now if we come up here, we're going to see we have a problem. All right, and that issue has to do with this red up here. If we hold our mouse over it, it says, hey, not all codes lead to, not all code paths return a value. And it's upset because we have this code and we have this code, but it's thinking, hey, if it's this and if it doesn't meet these two conditions, we're not going to return a value, but it's going to have to meet those two conditions. So we're going to just return a -1 at the end. All right, and I'm also, just for, and I do this sometimes, just for debugging purposes, I'm going to put in a little message box, and I'm going to say the compare to method for Celsius is not working. Okay, because it's either going to do this or this. And if I get a -1, I don't want it to be because something messed up here. And I just assume it's right there. All right, so we finished the compare to method for Celsius. Now let's go ahead and do the same thing for Fahrenheit. It's going to be very similar for Fahrenheit. Okay, so public override int compare to. All right, and we're going to do the same thing. We're going to check first and see if it is a Fahrenheit. I have to spell it right. If T is Fahrenheit, it's going to be a lot easier to make that comparison. Okay, if this temp equals the T temp, they're equal. We're going to return 0. That means equal. Okay, else if this temp is less than the T temp, we're going to return a -1. Else, we're going to return a 1. All right, now why is that? Oh, got to spell it right. I'm having trouble typing today. All right, so there's our first one. Okay, so now we have to do the other type if T is a Celsius. This is going to be a little bit more difficult to compare. Okay, so if T is Celsius and if this dot temp equals to T dot get conversion of the temperature. Okay, and I'm going to do this first before I do the math dot round. Let's look at that. If this temp is equal to the one that's, yeah, okay. Now I'm going to go back in. Since there may be a round off error, we're going to go ahead and put in the math dot round. Math dot round. Okay, and that's going to be for 0 decimal places. Get that right? No, because you have to use the object to call the temperature T dot get conversion. And then we don't need that right there, do we? Okay, so if math dot round T dot get conversion 0 decimal places, and we need another parentheses. Okay, if that equals this temp, we're going to return 0. Okay, I don't like the way it did not. Oh, oh my gosh, I put a semicolon after an if. That is horrible. All right, because then it wouldn't execute anything, right? Okay, so I'm just going to go ahead and let it, instead of adjusting, let it do it, the alignment for me. Okay, so if this temp equals math.round T get conversion to 0 decimal places, return 0. Now, if this temp is less than, and then all it is then is typing. Okay, so if it's less, return -1, and we need else. And then the last one is going to return 1. Okay, and we're going to go ahead and we're going to take care of our all pathways problem. And before we do that, we're going to do a little strategic placement of problem solving, debugging, because it should never get there. There's a problem with the compare to for Fahrenheit. Okay, and those can be taken out before you submit. And again, my message box is not working because I've got to import system Windows form. All right, great. Okay, all right. The only thing we have to do now is write our code for the form. We're almost done. Okay, the first thing we're going to do in our form class is we are going to go here and we're going to create two global temperature variables. We're going to declare them. Temperature temp1 and temperature temp2. Alright, now we're going to come down to our button click. That's where all the action takes place. Okay, let's see. Creating the right type of temp for either Celsius or Fahrenheit scale. Okay. Alright, so and we're going to look at a list box. We called it list scale 1 text. If list 1 text equals Celsius, then we're going to make, I did it again. Then we're going to make temp1 equals new Celsius. And we're going to use that default because we don't know the temperature yet. Okay, so else if the scale 1 text equals Fahrenheit, temp1 is going to equal the new Fahrenheit. And did you notice when I created the objects up here, when I declared them, their temperature, right? Because that's the base class. So, oh, and I'm sorry about that. Let me take care of my typos right here. Else if L, and I misspelled again. I like to transpose those letters. Okay, so since we declared them as temperatures, they could be either a Celsius or a Fahrenheit type of object. Okay, so that's how we declared them as temperatures. Then we determined what type of temperature it was by what the user selected. Okay, now we need to do the same thing for the second list box. Type of temp, the type, creating the right type for of temperature for either, okay, it's the same thing. All right, so if scale 2 text equals Celsius, and if scale 2 text is Fahrenheit, then temp 2 is going to be the right type of object. All right, great. Now we've got to assign a value to the either to a Fahrenheit or a Celsius temp field. All right, so now we're going to make an assignment for when they put in the text box the temperature for each of those. Okay, so since we're going to try to parse the temperature or convert it, we're going to go ahead and put it in try catch. Okay, let's call it new temp convert to double the text box temp1 text. I'm going to try that. And then we're going to make the assignment to the temp1 object's temp field. Alright, same thing for the second one. Okay, so double temp, we'll just add a 1 to it. Convert to double text temp to text box, and then text temp 2 equal new temp 1. Okay, just be sure that if you copy and paste that you make a new identifier and that you get the correct text box. And we got temp 2 equal temp 1. Okay, so that looks good. Alright, so we're trying that. Okay, now we need a catch. Okay. The catch is going to be a message box. Now, I'm going to say you must enter a number for temperature, but also you have to select the right scale for both temps and select the right scales. If they don't select a scale, we're going to have an issue. If they just choose not to click on one of the list boxes, we're going to have issues. So I'm just going to take care of both of those right there. All right, now we're going to do, the only thing, we've got our objects and we've assigned the temperature field for each of those. Now we're going to do the comparison to see which one is, oh, I didn't put in my, if you pay attention to your alignment, you can catch yourself making common errors. Okay, so int compare equals 0. All right, so compare is going to be equal to temp 1 compare to temp 2. All right, so we're going to take our first object and we're going to tell it, hey, compare yourself to the second object we created. All right, and we're comparing the temperatures. Well, it's going to do that. We wrote it that way to compare temperatures. Okay, so we're gonna. So the next thing we're going to do is we have to decide if it's equal, greater than, or less than. So if compare equals 0, then our temperature label text is going to say they're equal. I'm just going to put temps. Okay. Else, if compare is less than 0, our label is going to say, okay, so if it comes up with a negative number, the first temp is cooler than the second. All right, else we're going to say the first temp is warmer than the second. Oops. All right, now I've got a lot of red. Let's see what's going on. Did not put a semicolon in the first statement. If compare equals 0, okay, I've got a lot of red. Okay, so we've done everything except compare the two temperatures. So let's go ahead and do that. It's the last thing we have to do. We're going to make a variable. Okay, and then we're going to assign the variable. Why don't I do temp 2 first? Let's do temp 1. Temp 1 compared to temp 2. All right, so now we have to just decide what we want our label to show. So if compare is equal to 0, our label is going to say that the temps are the same. All right. I'm getting some red here. Okay, maybe I don't have a label temp here. Let's see if I can temp compare. That's my label name. All right, so I'm just going to go ahead and okay, so if it's equal to 0, the label is going to say they're the same. Else, if compare, it's lowercase, compare is less than 0, our label is going to say the first temp is cooler than the second. All right. Else, our label is going to say the first temp is warmer than the second. All right, all we have to do now is test. All right, now since this lecture has taken a lot more longer than I expected it would, you've had to listen to me for so long, I'm going to let you do your testing on your own. I hope that as we went through this exercise that you understand a little bit more about inheritance, how interfaces work, and what abstract classes are and how they work as well.